Hi friends, welcome to the lecture on EMF. In this lecture, I am going to explain you calculation of inductance of different conductor configurations. Before going into the discussion, let me introduce myself. I am Satyanarayana Vanapalli, working as Associate Professor in the Department of Electrical and Electronics Engineering, Guntur Engineering College, Guntur. In this lecture, first see what is meant by inductance. As we know that according to Ampere's law, there exists a magnetic field surrounding a conductor that is carrying current. So, if you take a conductor, what might be the shape of the conductor? That was immaterial. Then there exists a magnetic field when current is flowing through the conductor. So here, this is the direction of current and this is the direction of magnetic field. And with the help of Ampere's law, we can find out or we can establish the relation between current and magnetic field. Integral H dot dl is equal to In plus, where H is the magnetic field intensity. So, the value of this magnetic field intensity will change based upon or depending upon the magnitude of current. So, we can say that clearly a value, or in a word we can say it as higher the magnitude of current that was sent through the conductor, higher would be the magnitude of or intensity of the magnetic field. Okay, now we can relate this magnetic field with the flux density. So, let B is the magnetic flux density. Then this H is equal to H and B are related to each other as B is equal to mu naught H. Then the amount of magnetic flux that leaves the surface phi is equal to integral B dot dl. So these are the relations that you have learned so far. Now we define inductance of a coil. Here the inductance is the property of a conductor that was exhibited by the conductor, current carrying conductor. So that what happens is the current carrying conductor establishes a magnetic field surrounding it. Because of that, magnetic flux density can be observed. This magnetic flux density results in magnetic flux lines. So this magnetic flux lines links with the conductor. So so that the conductor is bent in the form of a circle. Then the current flowing through it would be, say, in the clockwise direction. Then the magnetic flux lines would be like this. So inside is a dot and outside is a cross. That means within the loop the current would be into the board, and outside the loop is the current would be outside the board. Okay. So if there exists more than one such loop, then what happens is the current direction is same, but because of the second loop, pi is the flux that was produced. Because of first loop, pi is the flux that was produced. Now here the flux or the total flux that is linking with the conductor is flux that was produced by the first circle plus flux that was produced by the second circle or the second conductor. So the total number of flux linkages is equal to 2 pi. Here this is called as a turn or turns. This is called as turns. In general, this value is represented with N. So now we define inductance. So the inductance of a coil is defined as a ratio of total flux linkages to the current which they link. To the current which they link. So in this scenario, I is the current that was flowing through the conductor. Because of that, flux pi is getting produced because of one turn. Then if there exists n number of turns, then the total number of flux linkages is equal to n into pi. Total number of flux linkages is equal to n into pi. So it is the ratio of total flux linkages to current which they link. Because of that, n pi is the flux that was produced by the current divided by I is the current that is producing these n pi flux linkages, so that n pi by I is defined as inductance of coil. Inductance of coil is represented with the letter L. L is the symbol used to represent inductance, and the unit of inductance is Henry. So if suppose that a coil containing n turns carrying a current I amperes and produces a flux pi, then the total flux linkages is equal to n pi. Then the inductance L is defined as, you know, that total flux linkages divided by the current to which they link. So L is equal to n pi by I. In general, this inductance is known as self-inductance of the coil. This inductance is known as self-inductance of the coil. So this is how we can define inductance of coil. In the next class, I explain. In the next lecture, I explain you how to evaluate inductance of a solenoid. Thank you. Thank you for watching my lecture. Stay tuned to my channel for watching more lectures on electromagnetic fields.